Today we are going to move on to 3.2 logarithmic functions and their graphs. We're going to convert between exponential and logarithmic forms and describe transformations of logarithmic functions. So we're going to have h and k's again, and they're going to do exactly the same as they've done before. Yes. Logarithmic. Logarithmic. Like rhythm. Like rhythmic. Logarithmic.
Where's the H? Just say arithmetic.
You're going to find out. You're going to find out.
Logarithmic.
There's no A. There's no A. We just said
Yeah,
okay.
Logarithmic.
Stop acting like Jeffrey.
Okay, why are you attacking?
So a logarithmic function, every function of the form f of x equals a to the x passes the horizontal line test. That graph looked like this, yes? An exponential function looked like that, yes?
Mm-hmm.
Did it pass the horizontal line test?
Yep.
So that means it has an inverse, and its inverse is also a function. That inverse is called a logarithmic function base A. So what a logarithmic function is, we got a lot of conditions. A have to be bigger than 0, and A can't be 1. Now, remember when we were talking about exponential, was 1 an exponential function? Was 1 to a power an exponential function?
No.
No, it's a constant, isn't it? It's always 1. So that's why A can't equal 1. Okay? So what a logarithmic function is, y equals log base A of x. That A is small. And if you don't write it small, you're writing it wrong. Okay? That A is small. It's log base A of x if and only if x equals A to the y. So if and only if goes both ways. So x equals A to the y if and only if y equals log base A of x. Okay, inverse functions interchange what two things? You guys have done this before. They're x's and y's, their domain and range. They reflect across that nice y equals x line. Okay, so domain and range, x and y's interchange places. Okay, so let's look at this. In this right here, y is the range, correct? And x is the domain because I'm plugging in an x and I'm getting out a y. So when I come over to the exponential function, my x is the range now, isn't it? And my y is the domain. So that's what it's doing. Okay, so we have some things that's, like I said, it is read log base A of x. It's not log AX. It's log base A of x. And this is just called the main thing you need is this right here.
Yeah.
Okay, so let's talk about why x has to be greater than 0. Well, is there any exponent that can make a base negative? No, there's no exponent. I could put a negative in front of the a, right? But there's no exponent that can make it less, right? So that's why x has to be greater than 0. A has to be greater than 0 because, well, the absolute value of a, basically. 1 isn't an exponential function, and I hope you would all realize that 0 is not as well, correct? Because 0 to any power would be 0, and would be that. Okay, so what we're going to do is we need to, switch back and forth. We have logarithmic here, and we have exponential here. When you switch them back and forth, so I have 2 equals log base 3 of 9. So my domain and range have to switch. Okay, so it's going to be my base of my logarithm becomes of the base of my exponent. So 2 equals log base 3 of 9 is 9 equals 3 squared. Now, I would write it the other way around, but that's what the book did in my exchange. I would put 3 to the second equals 9. Are these two statements the same? Yeah. Okay. So, do you see this? That the base of the logarithm is the base of the exponent. Okay. And the of becomes the equals. And the equals becomes the exponent. So if I can go from logarithmic to exponential, I should be able to go from exponential to logarithmic, yes?
Yeah.
Okay, so it's 5 to the third equals 125. So the base of the exponent is going to be the base of my logarithm. And these two things are going to interchange places because they're the range and domain. So I have log base 5 of 125 equals 3. You need to be able to switch back and forth because the whole point of the inverses are to allow us to solve for things we can't get at. Okay? So if I had an equation that had 5 to the x minus 7 equals 28, okay, I can't get 28 to the power of 5, can I? If I could use my 1-to-1 and I'd be all good. So I would have to use logarithms to do that. What would my base be? What would my base be?
What's under the log?
What would my base
Five.
of the 5? So this would be the same as saying log base 5 of what?
28
28
equals x minus 5.
equals x minus 7. And this 28 I would put in parentheses. And then I would add 7 over, yes?
Where did you add the 7 to?
You have to, you just at the end. Because
Oh.
the log base 28 is a function you would have to do. That's why I would put parentheses around the 28.
Okay.
Okay? So I could put this in a calculator and get the answer for x. You see that? But could I get at this x right here the way it is?
No.
No. That is the point of this. Okay? So if I had something log base 7 of x plus 3 equals 38. Okay, I'm obviously solving for that x, yes? Can I get at it? Can I get it? No, it's stuck in there, right? So I would switch it from logarithmic to what? Exponential. So what would my base be? What's my base? 7 to the what?
To the 38.
To the 38 equals x plus 3. And then I would just subtract 3, correct?
Yeah.
So x would equal 7 to the 38 minus 3. And you do that all in your head, right? 7 to the 38?
Yeah.
You do that all in your head?
Yeah, of
Yeah,
course.
because you're amazing.
Mhm.
Then I'd pull out a calculator and I'd solve it.
It's at least
And then you
over
get like
1,000.
x to whatever.
Right. You would get this answer in scientific notation, I'm sure, because it would be absolutely huge, right?
I can tell you that that is more than 49.
Yes,
Let's go.
by a few times. Okay.
Yeah.
So the whole point of this is to switch back and forth. Okay, so in here I just said switching forms can be very valuable when solving logarithmic and exponential functions. When it comes and you guys go, I don't know how to do number 38. And I said, well, what form is it in? Logarithmic. Okay, so what did you do? I couldn't do anything. What should the first thing you done probably? Switch it to exponential.
Don't we already have one?
Yeah, we're just going to switch around. Did we
Yeah,
write it on?
already switched it.
So we did like all the examples.
No, we
on
just
it.
did the first one.
The first one?
And
And the second one.
And the second. No, we didn't. do the
Yeah,
second.
we do.
The second one
Oh,
had a
it's 5 to
different
the 3.
thing.
Sorry.
Yeah. Okay, the first one is just going to be what?
3 squared. equals
3
9.
squared equals 9. Does 3 squared equal 9?
Yes.
Yes. So we're good. 9 equals 9. Okay? But anytime you get stuck, because I'm have some rules with logarithms and stuff that we can use. Anytime you get stuck, the next thing you should do is switch forms. That's what you should do. Okay, so this one we're going to actually solve. Because this is the same as y, isn't it, over here?
Yeah.
Yeah. So in the book, they just have a log base 2 of 8. Put a variable on the other side, okay? They say solve it, just put it equal to something, okay? So this is y. So
So 2 of y.
2 to the y equals 8. Well, now I probably should do my base, my 1-to-1 property, yes? When the bases are equal, the exponents are equal.
Yeah.
So what base am I going to make it? You're going to go to 2 or are you going to go to 8?
2.
2. So 2 to the y equals 2 to the third. So y equals what?
3.
3. So now I've got that exponent where I can't get it, and I could use the one-to-one property, yes, but I'm going to, could I use the one-to-one property on the next one? Yeah, but I'm going to switch it into logarithmic form,
Okay.
okay? So it's going to be log base what?
5,
5
25
of 125
equals
equals
x.
x. Now I'm going to tell you right now, guys, you are always going to use the one-to-one property if you can. Okay.
That would have been way
Right,
simpler
but I
to
just want to
do.
show you how these
Yeah,
all
For
interconnect.
sure.
Okay, so when we get something like this, we want to see if we can make this number to the same as 5, which would be 5 to the what? Third. So I have log base 5 of 5 to the third equals x. Yes?
Yes.
Now there's a property you're going to learn in a minute that would tell you the answer right now is 3. But you don't know it yet. So the only thing I could do is put it back at exponential, yes? Okay, so what's my base? 5 to the
3,
X.
x equals what? 5 to the third, and x equals what? 3. I wanted to show you how those work together and why the one-to-one property works. Do you see that now? Okay.
But I was gonna say, isn't it just the one-to-one property?
Yeah, it is. But I showed you why the one-to-one property worked, because you guys just believe me. You're just like, cool.
Oh, why
Why
not?
not?
Why not?
Why would you lie to us?
I could just tell you anything.
Yeah,
Okay.
probably.
So it says use the definition of logarithmics to evaluate. And I hate, this is so stupid, but the book does this, so I put the examples like this. They say log of f of x equals log base 2 of x, and x is 32. So what do you have to plug in?
32.
32. It makes no sense, but
Why wouldn't they just put,
put 32 in there. But they do. They do it that way. Okay, so I'm going to make it y equals log of 2 to the 32. Of 32, not 2. Sorry. So y equals log base 2 of 32. So I don't know how to calculate logs yet, right? Okay, so I need to go from logarithmic to what? Exponential. So try that. Remember, the base is the base, always. Base is the base. You want to take a stab at it? Are you guys just finishing the problem? Okay.
I don't know.
It's still working. Okay, Katie, go for it.
I have 2 to the y equals 2 to the 4. Does that equal
Well, 2 to the y equals 32.
Yeah.
And
But
no, it's not 4.
I don't know what it is.
Isn't it 5?
Yeah. That's what I had, but then I got 4 the second time I did it. And then
4 is
so
16.
then y equals 5.
Yep, so y equals 5. 4 is 16
Yeah.
because
I messed
2
up
is 2
on
is
that.
4.
I had 5 the first time, and I'm like, I'm gonna redo it. Then I get 4 the second time.
Yeah.
But here we are.
Okay, did you guys get 5?
Yeah.
Not hard, is it? We just have to get things so I can use them and manipulate them. Okay, so this one is what? Y equals log of 3, log base 3 of what? 1. So it's going to be 3 to the y equals 1. What is the only power that gives you 1?
0.
0.
Zilch.
So this is 3 to the y equals 3 to the
0.
0. So y equals 0. This is the work I need to see, guys. This is it. The only thing maybe over here, you could have gone straight from here to here if you wanted to. But I need to see all this work. I need to see you tell me that you know that 3 to the y if that's 0, okay? I need to see that going on. Okay, so y equals log base 4 of 2. 4 to the y equals 2.
Would it
Would it be a
half?
half?
It would be a half, yes, because it's the square root, or you could change 4 to 2, yes?
Yeah.
So you could do 2 to the 2y equal 2 to the first, correct? So 2y equals 1, so y equals 1/2. Or you could have done what you guys were saying. You could have said 4 to the y equals 4 to the 1/2, yes?
Yeah.
Okay? Either one of those you see, use it. Got it? Okay. Y equals log base 10 of 1/100. So 10 to the y equals 1/100, which is 10 to the what? What? Well, it's 10 squared is 100, yes? But I gotta get it from the denominator to the numerator, so I have to do, what do I have to do to the exponent? What exponent reciprocates stuff?
Negative.
Negative. So it'd be 10 to the negative 2? Yes?
Yeah.
Okay, you gotta remember those negative exponents. So y equals what? Negative 2.
Sorry, usually wants to get rid of the negative exponents.
Well, when you put a problem in the last final state, yes, you would get rid of it, but you still have to remember that they reciprocate things. Okay, so now you have a calculator. It has a log button on it. It's right there. It says LOG. Okay, now guys, look at what's the second. It says 10 to the x. Why do you think 10 to the x and log are right together?
Because
X-
when you use scientific notation,
No. Exponential and logarithmic functions are what of each other?
Inverse.
Inverses, so that's why they're on the same button. Okay? And log, just log, is called the common log function, and it is base 10. Okay? So if I would write y equals log of 6 and tell you put that in exponential form, what is my base? 10. So it'd be 10 to the y equals 6. And then you would have to go from there. But you wouldn't, because you could put log of 6 in your calculator, right? But this button right here is only base 10. We will learn a change of base formula that allows you to put other than base 10 in your calculator, but that button is only base 10. Okay? Clear? And so if it says approximate using logarithms, what are you going to do? Use your calculator and use the button, right? I think when it comes up, you hit log, and it has a parenthesis, so put in the parenthesis in. Okay? Now if I have log of x plus 6 minus 7, this is obviously what's in the parentheses. This is outside the parenthesis. Can anybody tell me what that is and what that is? H and K. How do we know this is an H? Because it's grouped with the what? X. This is K. Could I have written it like this? Yeah. It's still K, right?
Yeah.
I'm going to tell you this is the way I write it more. You ready to tell me why that maybe I do that?
other than it's obvious that it's a negative.
It's obvious that it's a negative, and it's obvious that this is my K, right? I will tell you I wish the book used more parentheses, because the book will just put it there. So it won't tell you, like, they'll say log of x plus 7. Okay? So they just, is it an H, is it a K? It's not grouped, so it has to be a K, correct? But wouldn't it be more clear if you just went like that? Yeah. So when I write it, I will be using more parentheses than the book does. I would encourage you to do the same. Okay, here's some properties that I actually just showed you. Okay, look back at the second example that we just went over, and you had something and you had 1 for an answer, yes? Like it equaled 1. What did we get for an answer? 0. Log base anything of 1 equals 0 because a to the 0 equals 1. This is from logarithmic to exponential function. Actually, we did almost every single one of these already. You just didn't know it. Okay, log base a of a equals 1. Well, because a to the first would equal a, so it's 1. Yes? Now, I choose to forget about number 2 and just focus on number 1. Gosh, I can't talk. I don't even think about number 2. I focus on number 3. Because it's like yesterday when you had your formulas, I gave you the first compound interest formula, right? And then I said, but don't use this one. Use the one that's going to work every time. Okay? 2 and 3 are exactly the same rule. 2 just happens to be x is a 1. Wouldn't it work for 3 as well if x was 1? Yeah, because it's just the degree. So if the bases are equal, your answer is the degree. And they call that the inverse property. And then they write this in exponential. I mean in logarithm. Yeah, exponential with the logarithm. Do you see? Okay, here base and base, yes?
Mm-hmm.
So it was the x. So over here is my base and my base, the same?
Yeah.
Yeah. So it's just whatever this is. If that was a quantity, that would be the answer. Okay. So, and then we've got our dot property as our one-to-one property. If I have a one-to-one property with exponents, shouldn't I have a one-to-one property with logarithm? Yeah. So if you have log base a of x and log base a of y, if this is the same, if the bases are the same, what's the same again? The exponents, but here it's the evs. Okay? But it's the same concept, right? So these rules can help you. You don't have to know them because you could do them. We just did them on the last slide that we did examples. We did all these. And I didn't know the rules, did it? But if I know them, will it make my life easier?
Yeah.
Yeah. If you use one of these rules instead of work, you need to say R1, R2, R3, R4. What does that mean? Rule 1, Rule 2, Rule 3, Rule 4. Just write it right next to it, okay? Because that makes me know that you are using work, not just Bob. Got it? Now, your assignment is like 7 through 32, all of them. Do these take long? No. Do I want you to be automatic when you're doing them? Yeah. So,
So we're gonna need a calculator for the homework.
there may be a couple that say like approximate this, but no, in general you shouldn't need unless they throw out some of those.
It'll be like the first ones that we did make.
Oh yeah. Okay, so simplify log base 4 of 1 using my rules. Well, log base 4 of 1 should equal what? 0. By what rule? 1. So I would put R1 next to it. That would be my work. Get what I'm saying here now? Now I'm going to tell you I don't use rule 2. I use rule 3 all the time because it's the same rule. Hey, log base square root of 7 of square root of 7, this is how they put it in the book. Put it equals something, okay? I don't care, x, y, something, okay? It just seems weird. So the base and the of are equal, correct?
Mm-hmm.
So the answer should be the exponent of the of, which is what? No, the exponent's a 1, isn't it?
Oh,
If there's no power on something, the power is 1. Okay? So the answer is what?
1.
1.
R2.
I'm gonna do it by rule.
Or just here, just equals 1. What?
Don't
What do
you
you
need
do?
R2?
I would put R2, I would put R3, but could I put why can I put R3? Why would I say I would use R3?
Because it's basically saying.
Because the exponent was what? 1. Okay? You want to use R2, use R2. I don't care. It's either R2 or R3, correct?
Yeah.
Okay. So, not log. 6 to the, this is all an exponent. Okay, so some of you sloppy writers need to get neater.
Okay.
6 to the
Okay,
log
okay.
base 6 of 20. Are my bases equal? Yep. So my answer should be what? 20. Rule 3. And I didn't give you one for 4, so let's see. Log base, give me some weird base.
3.
3?
Oh,
That wasn't weird.
27.
27. We'll do 27. No, we'll do 29. Equals log base 3 of x.
X equals 29.
X equals 29. And someday I'm gonna like copyright the duh property. Because it's a duh, right?
Yeah.
If this equals this, the only way it can happen is if x equals 29, right?
Man, the
Now if this was x minus 7, I would just add 7, yes? So I just finish out the problem. That's how you use them to solve equations. Okay? So you have these rules that you can use, and it will say using the rules. Okay? So I want to see you using the rules. So if there's no really rule to do, you're going to do what? I want to know what rule you're using, okay?
So as long as we put what rule we're using, we don't really have to show
Yeah,
work.
you don't really have to show work.
Is there any time where R2 won't be R3?
No. Because the power on R2 is 1, correct?
oh, so it's
So
also
it
gonna be
is
the same
it
thing every time.
is R3.
There's
This
one-
is a specific rule, yes?
Yeah.
This is a general rule.
So you don't care which one we use.
No. I like to limit the thing. If I don't have to remember rule 2, I'm not going to remember it. I have other things that I got to waste my time on, right? So there is no time that rule 2 could not be classified as rule 3. Now the book would probably tell you it's rule 2 anytime there's no power shown, but they are the same rule.
So we don't really have to use R2 pretty
No.
much. Okay.
But like I said, if you're looking in the book and they say it's R2 and you say it's R3, you're not wrong. They're just gonna
they're being
gonna
specific.
right. They're using the specific rule.
And it won't be counted around for us, right?
Okay, so the graph. They are inverses of each other, yes? And inverse functions interchange range and domain. And they reflect across this beautiful
X equals 1.
x equals y line, or y equals x line, either one. Slope of 1, y-intercept of 0, correct? So we're going to review our exponential information. Haha. What is our domain on an exponential function?
X such that is 4 on
Okay, x such x is all real numbers, correct? Put anything in it. What is my range?
Y such that real numbers?
No, this is your x-axis. That looks bad. It's everything greater. It's never 0,
Oh,
remember?
okay.
So it's y such that y is greater than 0. And this is the parent function, right? Okay, so then we don't have a vertex on this one, do we? But we do have a y-intercept, correct?
Yeah.
So the y-intercept was what?
The Y. 1.
0, 1?
Yeah.
Okay, y is the y-intercept of an exponential function 1. Because anything to the 0 is
1.
That is y, correct?
Yeah.
Now, it's increasing, it's continuous. I don't care about any of that stuff. You guys care about that stuff?
Nope.
I mean, that is obviously increasing and continuous, yes? Okay, so if logarithmic, and you see the picture there, right? You see that picture. If logarithmic is the inverse of exponential, range and domain will switch. So domain,
x such that x is greater than 0.
yes, x is greater than 0. Do you see that on the picture?
Yeah.
Yeah. The y-axis is a vertical asymptote, isn't it? Okay, so then my range is going to be what then?
Y is such that all round numbers.
Well, yeah. All real numbers. Good job.
So there's flip-flops.
Yes, because that's what inverses do. And I don't have a y-intercept anymore. I have a
X-intercept.
x-intercept because this point goes from 0, 1 to what?
To 1.
1, 0. So it would be a x-intercept. Now, if I know what my exponential function stuff is, and I know their inverses, do I have to remember what logarithmic is?
No. You just need to
Technically-
remember one.
I just need to remember one. If I know logarithmic, because I like it better, I don't know why, can I just remember that exponential is the opposite, is the inverse of it?
Yeah.
Yes. Or could I remember both if I wanted to?
Mhm.
Yeah. You know what I do? I draw a picture. Honestly. If somebody would ask me to tell you the characteristics of an exponential function, I would do this. 2 seconds, yes?
Mhm.
And then I go, okay, got it. No matter how long it's been, I have to give myself a picture because then it triggers that in my brain. But if I know one, do I know the other?
Yeah.
Okay, so over here, it was y equals plus or minus a to the, and it could be plus or minus x, yes, minus h, plus k. H and k, left, right, up, down, reflected over the x-axis, reflected over the y-axis, everything right? Okay, so over here, we have y equals plus or minus a log, oh, I need to do it different. We're going to say b, because I put an a there, of x minus h plus k. Oh, and there's a plus or minus there. Okay, so plus or minus here reflects it over the
X-axis.
x-axis. And what's this plus or minus do? The y-axis. What's this h do?
Horizontal.
Horizontal. Left and right, correct? And what's that k do?
Up and down.
Up and down. Now, remember the horizontal is always the opposite direction, yes?
Yeah.
Now, be careful though when you have this, if you have a reflection here, it does some goofy stuff, but we won't do a whole lot with that. But if I reflect that over the x and the y, it changes it, doesn't it? It changes because there's only one piece to it. There's no symmetric. There's no symmetry to the graph, is there? So, I'm still sticking to my promise that everything stays the same, right? Now, I don't know why I assigned 37 because 37, 38, 39, and 40 are like matching. Does that make sense?
Yeah.
So you could, well, you have to do it today or you have to do it Monday. So if you want to just practice just matching it to a picture, do 37 through 40. There's 4 graphs and there's 4 equations.
Do you have to do 340?
No, but you're going to have to do it either now or Monday. And we just went over this. You might want to do this to keep it in your brain for Monday.
So if I do
So from
37
Monday-
through 40, I don't have to do it.
Right,
On this side.
right. If you do 37 through 40 today, you don't have to do it Monday because we're not going to do anything else with graphing today. I wanted just to introduce you to the graph. Now, 37 through 40, I didn't give you any examples of what it does to this, did I? Okay, so that's going to be you deciding, okay, it goes, what point am I moving on logarithmic? What point am I moving? The x-intercept at 1, 0. So you got to think about what that does. Now, you're probably going to have questions on those, and that's okay, because we're going to do more examples and stuff with that on Monday. So this gives you time to get your assignment started, guys, and it goes really quick. Takes longer to write down the problem usually than to do it.
So this assignment will be due on Monday.
Yes, this assignment will be due on Monday.